Right. So today we are going to look at Mastra AI. And Mastra AI is a framework, an agentic framework, basically. It's built around TypeScript. It's built on TypeScript. So it's meant for the front end. But since it's TypeScript, you could also use it on the back end as well, for Node.js backends, right? So we are going to look at what is an agentic framework and why agentic frameworks matter. We're going to look at Mastra's core abstractions and how Mastra helps us do all of the things we have done in the last few weeks and months in this class. Mastra will help us do some of them even better. So remember, we went from writing stuff on our own, prompt chains, and all whatnot, to using LangChain. LangChain made a lot of things easier, right? And including making agents, and then the agentic framework, the agentic React, loops, and so on. Now, Mastra is going to go even a step further to make it even easier for us to build all of that. So we'll talk about that, and we'll talk about how to integrate Mastra into a Next.js app. So we're going to just start a simple Next.js app like we did last time. But this time we're going to use Mastra to build, and we're going to use Mastra to build a real front-end agent. So in this case, we are essentially moving the whole thing um, to the front end, right? In the past, remember, if you remember, there is a similar slide to this where we actually saw that the line, right, where we had a shift, okay, where um the traditional apps, right, used to be. In fact, let me bring up that slide so that we can look at it and compare, right? That's what we did in week 11. So if you remember this slide, there's a slide here where I was showing us how we have evolved, right? From traditional AI application, from traditional web application to AI native application. And I think one of the key things that you remember we talked about was where is the line drawn, front between the server clients. This is the where the line is drawn, right? And then in an AI native app, the line is still drawn here. So this whole section, right, is at the back end. This whole section is at the back end. Let me use a double arrow. This whole section is at the back end, right? That's what we have been doing since, right? We've been doing this since. So this whole section has been at the back end. Now we are going to do something different with Mastra AI. It changes, right? With Mastra AI, we now basically move it to this point where you could do everything at the front end and only the models. Well, maybe the vector DB can be at the back end. Only the models now exist at the back end because Mastra provides us everything else at the front end. And that's what you will see with this new architecture, right? Kind of Mastra switches it. So we are now basically everything else here is in Mastra. It's only the LLM call that is at the back, right? Of course, the streaming UI streams back to you. So this is front end. So you really only have this very short, just the LLM is now at the back end. Okay. That is, so the early AI apps that we were using, which we just talked about, when we say early AI apps, we are talking about the last 3-4 years ago. Okay. Right. User prompts from 2022 when ChatGPT came on, right? User, then the prompt, and then the LLM. So the line, in this case, the line is here because you do your prompt and then you get a response. So the response is here. And this is basically how it was. Now, modern AI apps have a lot more. You don't just prompt LLMs. There's so much more. You have the agentic framework, you have the agent, and then the agent orchestrates everything. So you have two calls, right? You have memory, right? And then you have this new thing called workflows, okay? And it's only the LLM that's still at the back end for now. Who knows, in the nearest future, LLMs will even move. We have edge devices, edge models that can actually run on your device. So we may even get to a point where the entire stack can run on the front end, which is what people are looking at. So what Mastra does is that all of this now exists in Mastra, okay? And you only call out to the LLM at the back end. Of course, the LLM has, Mastra has what we call routing, which allows you to decide to choose between different LLMs. So what we now see is that in today's apps, today's AI apps, right, calling an LLM directly does not work anymore because you need tool usage, you need multi-step reasoning, right? You need persistence, which is memory. You need observability. You need to see what's going on. You need streaming and evaluation. I know how much I struggled with just implementing my own streaming last week, even though there were libraries for it, but it still didn't work, you know. So that entire infrastructure for you to implement intelligence, because we want people to be able to focus on the business need, the business logic of intelligence, not the infrastructure of intelligence. I shouldn't be struggling to figure out all of these, you know, moving parts when I really just want to use my intelligence to maybe, for example, allow an enterprise or a user to access something. So I focus on building the application, right? So Mastra provides this whole infrastructure for intelligence, not just the inference. The inference is just the LLM, but so that's where the value of Mastra comes in. The fact that you are able to do that. So what is Mastra AI? Mastra AI is an agentic framework, basically, for building production grade AI apps. So the key design philosophy there is agents. It starts with agents, right? Because, well, you don't need to go do everything again. So agents are first class, you know, objects. They are type safe, right? And it's built with the modern web stacks, right? It's built for modern web stacks, rather. Streaming first. So we talked about streaming. Streaming is a key element of the user experience for AI apps. You don't want to wait until the whole generation is done before you begin to show the user what has been generated. So Mastra, they have implemented streaming, made it easy. And we're going to talk about that shortly. It's tool native, so you build tools, right? It's easy for you to build tools. It's provider agnostic, so it doesn't matter which LLM provider you're using, okay? That's why it has what we call routing. So you basically set that up similar to what LangChain does. The only thing is that with LangChain, you still have this chat OpenAI, chat Grok, chat Google Generative AI, you know, chat Hugging Face and all of that, right? So you still have to manage that, and you probably have to write your own code to switch between them. But Mastra does what we call routing, which allows you to just you don't bother, you're not really bother about which LLM provider you are using, right? Your code will still work either way. It's only at the point of setting it up you configure it, and it goes to that one, and it's production ready. So, Mastra AI is a front-end framework. Well, it's a TypeScript framework. So anything that runs TypeScript, it will integrate with it, including Next.js, even Vue, Nuxt.js, even Nest.js at the backend, right? It has edge runtimes. So, like I said, edge basically is on the edge, on the device. Okay, so it maximizes the things you can run on the device rather than always doing API calls to a server to get stuff. Server actions, it has server actions as well. It does streaming, React streaming. It has WebSockets. So that means it's easy for you to maintain WebSocket connection to the backend and do whatever you want to do through the WebSocket. So it gives you backend infrastructure that you can then build your intelligent software on top of. Okay. So I think we've talked about this already. The fact that front end is evolving is no more just a UI, no more just it's no more just a user interface, a dumb user interface to display information from the back end. It is now intelligence interface. So people will have to interact with your front end and not just interact, but interact intelligently. Your front end has to, exhibit intelligence. And we talked about it when we were talking about design for user interfaces. We talked about the things that you have to do, the things that matter, right? The things that make your application to exhibit or appear intelligent. It's not only just about the LLM or the inference or even the agentic React loop or even the reasoning, but even some smart things that you bring into your user interface. Okay. So that's what this is about. It's not just about rendering data, right? It now has to do reasoning, it has to make decisions, it has to orchestrate tools, and it has to adapt to user context, which depends on which user logs in. Its behavior may change, its options, its suggestions may change, and so on. So if you didn't have a framework, right, without a framework, you would have to manually manage a lot of stuff, like retrying, managing failures, like tool calls, like prompt chaining, the state, the memory, and streaming. Man, I struggle with streaming. I had to give up streaming last week, right? And when you try that, you see. But um, it becomes very fragile if you have to keep doing it each time yourself. So Mastra provides all of that. It gives you structured primitives that will allow you to build reliable agentic apps. So this is typically the architecture, how it looks like. So you think in layers, right? You have a models layer. So in this models layer is where the provider agnostic LLM layer comes in, the routing, where you can decide which models that you want. And then on top of the models, we now build agents. So the agents, remember, an agent is basically a model that you give two calls and you give it a reasoning loop, right? React loop, where it is able to keep reasoning and keep making two calls and then engaging the LLM as the reasoning engine and come up with something. So you build agents on top of models, memory tools, and RAG. So these two are, the things that make up the agent. And then workflows. So beyond agents, we have been talking agents, but now we are going beyond agents, right? Beyond agents, you now have the workflow. And this is very, very critical because when you feel that the agent is at the top of the food chain, then you have lost. You are losing already because effectively agent is just a tool. It's actually the first step, right? You now have to use the agent to do stuff. And that is where Mastra gives you a bit of, power because you are no more struggling around building the agent itself. The agent is the first thing you get out of the box, right? You get the agent first out of the box. So that kind of um, frees you up to start thinking of bigger things that you can do with the agent. And that's the workflow. The workflow allows to orchestrate, right? And then you have memory, which allows for persistence. And then you have tools. We already know tool calls give the agents capability to do things outside of themselves. Then they've added a server, which we're going to talk about, right? And then observability, and then streaming. So streaming is really powerful. It really helps with Mastra. Okay. So Mastra is not just an agent runner, it's a full runtime. It's a full application, AI application runtime that you can just build any application on top of it. So you can think of a Mastra like giving you a powerful runtime for your front end, right? And then you use LangChain and LangGraph to build your powerful backend if you need additional capabilities at the backend. Okay, so we're going to look at a bunch of the core abstractions in Mastra. The first one is the agent itself, of course. So remember, an agent is just an LLM that has instructions, right? That tells it how to run the React loop. You give it prompts. You give it tools, so it knows the tools that are available to it and what each of those tools can do, so that in its reasoning loop, it is able to decide which tool calls to make. Then, of course, it's memory, because intelligence cannot exist without memory. If you have intelligence without memory, well, imagine having a conversation with somebody who will not remember the last thing that you people discussed. That's intelligence without memory. So intelligence will not appear intelligent if there is no memory. So that is the third element. And then, of course, the model itself, which does all of um, the reasoning, right? That's the reasoning engine, is the one that will um, basically orchestrate, everything, decide on what to do and how to do it. So that's um, model. Then the output behavior itself. So once you give an agent is basically all of this, right? This is the scaffolding. When we say scaffolding around um, an LLM, this is the scaffolding. And once you have this scaffolding, then of course you have an agent. So that's basically it. Okay, so with Mastra, it becomes very easy, right, to just set up an agent. It's not a difficult thing anymore. Yes, I know LangChain kind of made it easy as well, right? But Mastra, you basically have a class called agent class, which you import from Mastra core, okay? And that's it. So when you are creating a new agent, you use new agent, to create an agent, you give it a name. So this is the first time you see a library that is talking about identifying, these elements. So you give it a name, and then um, you give it any instructions. So those instructions would be like, call it a system prompt. Okay, you give it a name, you give it those instructions. That is the system. That's the system prompt, and then you specify which model that is at the center or the reasoning engine for that agent, and that's it, right? Um, you can see that for now we've not mentioned any tool calls here, right? We don't have tool calls, but this is the basic method of creating agents in Mastra. Okay, now the next thing is the tool calls, like I said. So that's the next thing. After you create an agent, of course, an agent is not an agent if it doesn't have tools. And because it basically will not be able to do anything else. It's going to be limited to its hallucinations and so on. Okay, so in order to do uh, you know the tools, this is how you implement tools or tooling, right? Again, you import the tool from Master Core, then you create a tool. And creating a tool is as easy as defining, you give it a name again, which is a very good concept. You give a description. This is what the LLM will use to figure out when it needs to call this tool. And then execute. You can see that execute is basically the implementation of the tool itself, right? So you can see you have the execute, and then you have this as a callback in JavaScript. So this can be anything. It can be, you can just make a simple function like this. It can be a simple function, right? Or it could be a class. It could be anything, right? So that's the benefit of using Mastra. Okay. So once you have defined this tool, okay, when you are now creating the agent, so remember in the previous slide, you created an agent, specify name, instructions, and model. So you can also add the tools, right? Similar to what we have been doing with LangChain, similar to what we have been doing with all the others, right? So you basically use the tools and specify all the tool calls that um, you want to make available to this agent. So It's as simple as that. And with that, the agent can decide what to do with that tool call. So this is quite simple. So that's the first abstraction, which is the agent. Now, the second abstraction is workflows. So what do we mean by workflow? A workflow is the multi-step orchestration, right? Um, a React loop, right, or plan and execute loop is kind of very specific instances of multi-step orchestration. Because a multi-step orchestration is in a real world, in real production apps, the agent is going to do stuff multiple times, and we know this. And the multiple times is not even a question of um oh, I need this tool call, then I do the tool call, then I get the response from the tool call, and then I now use that response to reason some more. And if that needs another tool call, then I make more tool calls, and I keep looping like that until I get all the information I need, and then I can reason about it and give a response. That's just one, right? That's just one single React loop or one single reasoning loop, right? In the multi-step orchestration. After that, there may be a second step. There may be a third step. There'll be multiple steps. So these multiple steps is what we would call workflow. And so these are examples of a multiple step orchestration, right? So for example, I need information, I need to retrieve, then I need to summarize, then I need to store. Okay, that's one example of multi-step orchestration. The second one is I need to detect the intent and then route to the correct agent to do stuff. So you can see that there's even routing. So you could even have a situation where you have multiple agents, right? In an agent team, right? And you have an agent that his own job is to figure out which agent to route requests to. Okay. So that's another multi-step, right? But you need to, the first agent that's doing the routing needs to figure out what is the intent, what is the requirement. That is what will now determine, it will use that to determine which agent to route to. So another one is validate. Okay, do validation. If it is not okay, we ask for more information or we ask for a retry. But when it's okay, then we respond. So you can see that this is multi-step. Think of it like chains, right? But it is a bit more involved than that because each step can still involve a bunch of reasoning loops as well. So workflows will give you a deterministic structure around the probabilistic models. So you can now see how Mastra implements workflow here, right? You first of all import the workflow class from Mastra core. Then you can now run, create a new workflows. Of course, give it a name. Then the run method of that workflow, you specify what you are doing. So you have input and you have agents. So this is a good example, right? You fetch input, you fetch um, content from a specified URL, okay? And then when you are done, you then take that content and you can pass it to a summarizer, okay? If the workflow is to summarize a page. So a workflow is kind of like Mastra's own um, equivalent to a chain, basically, right? So, but it allows you to customize it and write, whatever you want. And yeah, so here I have a list of agents. So I have an agent that is a summarizer. I can then ask that summarizer to generate content based on the messages. So you can see this is a standard OpenAI message structure. Role is user, content is content. Okay. Now, the third thing that really makes Mastra what it is the streaming part. Like I said, streaming is very, very essential when it comes to AI user experience. You don't want to wait until your model has finished generating, before you start sending it to the user. Okay, so streaming output is very key. Once you implement streaming in your apps, a user will always prefer it because users perceive streaming as being faster and smarter and more premium, right? Um, if you're not streaming, what will happen is the user waits and waits and waits, like what you had on my own app, and then the response drops. But if you have streaming, you can almost get almost instantaneous response because the latency, um, these days, the LLMs are designed and trained to immediately begin to generate. And once they begin to generate, they begin to stream. So if you are reading from a streaming endpoint, you already have tokens that you can begin to push into the output, into the user. So the beauty is that um, Mastra has built-in streaming, right? So you can essentially just call agent.stream, okay? So in this streaming mode, you are already in streaming mode and you get the stream. And from that stream, you can just pull whatever comes from that stream and begin to write it, out straight into wherever you want to write it out, process or standard output, or if you want to push it into a chat interface or whatever, right? So we're going to try some of these things later on. You can see that in today's people are already used to streaming, so it's no more a feature. Like you cannot even be boasting and say, "Oh, I have streaming," right? It's kind of a baseline expectation these days. Then the other thing that Mastra will quickly give you access to is MCP. We already talked about MCP and what MCP means. It's model context protocol. So what this means is basically a standardized protocol that allows models to access information and ex interact with external tools, right? In order to um, get information, get new context, or execute tool calls, right? So that's basically what MCP is. So instead of having to build custom integrations every time, MCP allows you to use a single interface, a single approach to access any information. So it brings interoperability, right? It allows tools to be portable, it improves safe execution, and it gives structured inputs. So Mastra also has support for MCP compatible tooling. So that means that basically your agents can plug into, the currently growing AI ecosystems that have so many MCP servers and endpoints, right? And you don't have to rewrite or repurpose. So this is critical for future-proof architecture. Then, yeah, one other thing that you find you may be struggling with is memory. Memory, again, like we said, without memory, AI or intelligence of any sort doesn't appear intelligent. Of course, we know by default the LLMs are stateless. They don't keep track of previous conversation. They will reason well based on the context you give to them, but they will not keep track of any previous conversation. So Mastra allows you to implement memory. It already has a built-in first-class memory class, right? Which you can import, okay? And you just create memory, memory, new memory. Specify the provider of the memory, which can be anything. It could be Redis, Postgre, which is a database, anything you want to be the backend for your memory, where things will be stored, right? And we can even use vector stores, which is another example. We'll talk about that shortly. And you have different kinds of memory, short term, which is used to keep your conversation history, right? Then you have long-term memory, which you can use to store longer term store user preferences, which will persist across different sessions. So the next time I log in, I should still be able to see my preferences. And even previous conversations can be stored. Then you have semantic memory, which is memory that you use um, embeddings. You store them as embeddings, right? They have that as well. So the semantic memory allows you to retrieve contents that are relevant to the current conversation. And then you have structured memory, which is memory that is basically stored as structured data in database records. So each of these has its own uses, and we're going to look at some of them. So when you create memory, what you do is you can then attach it to an agent. So when you create an agent, just like we create a tool and attach to it, you can create memory and attach to it, right? So what happens is once you attach memory to an agent, then the agent uses that memory and will use it to persist whatever interactions that you have had, the conversation history and all of that. So if you choose to use a short-term memory, it means that the next time you create that agent, it will not have that memory again. Maybe you store it in session storage or something. But you could also choose to use a long-term memory, which can persist, somewhere either in preferences or even in a database or a semantic, storage. So what happens in that case is that the next time that agent comes back online, it basically still uses that memory and is able to access all of the information that was there. So that is the beauty of the memory. Then, of course, we have RAG, right? We have RAG. So we already know what RAG is. RAG basically allows you to bring external knowledge and inject it as context at the point when you are querying the LLM. And the LLM can look into that context and give you more useful information or more useful response, right? So essentially, RAG grounds the LLM in real fact, in real knowledge, rather than allowing it to hallucinate. So RAGs, you don't use RAG all the time, but like I mentioned before, it's always a good idea to have RAG available as a tool so that, but you have to define it. You could have like 4 or 5 RAGs, each RAG doing a different thing. So you need to be clearly defined what the tools, each of the tools that you tie to a RAG, what they do, so that the LLM can reason about it and decide which one is the right one. So different kinds of RAGs, documentation bots, SAS copilots, internal knowledge agents, research assistants, and so on. But the good news is that Mastra also allows you to easily access this by using this vector store interface. Okay, so you can basically search. You would have to first of all create, this is the standard RAG approach anyway. You create a vector store and then you get the context by searching based on the query, right? And then you pass that result, you you pass it into the agent. And you can specify the context as a system message. So this is just one of the examples or one of the ways of doing it. Okay, then we have workspaces. So a workspace is a way for you to organize your agents. So take note, a workspace is different from workflow. Workflow is basically a sequence, while workspace is isolated, environments that allows you to put your agents. And this is because, as your app is growing, you start having a lot more agents, right? And you have a lot of workflows, tools, memory layers, and so on. So if you don't have a way of organizing all of this, then you might begin to have issues. So the workspaces allow you to organize things, right? So you can think about it like with more of saying, okay, workspace allows me to do things that need to be together, and they cannot be leakage outside of that workspace. So it allows for composability, right? It allows for testability, it allows for isolation of environment, and allows for clean architecture. And this is how you do the workspace. So basically, you create a new workspace. And in this workspace, you can put all the agents that you want to be in this workspace. You can put in all the workflows that you want to be in this workspace and so on. So any agent that is not in this workspace will not have access to workflows that are in this workspace. Basically, this is how you control, basically contain everything into sandboxes and you create isolation. Okay. So there's another thing that Mastra also allows us to do, which is the Mastra server. So Mastra server is basically a server that allows you to run and as a server, as an endpoint, right? Um, s- because your agents will need a runtime, they will need something they can connect to. Yes, you can build servers with other things. You can build with LangChain, LangGraph, LangServe, and so on, right? You can use a fast API backend. You can use all kinds of things. But Mastra also gives you this, so you can essentially create an endpoint um, for your agents. So the way to do a Mastra server is pretty simple, right? You create a Mastra server using this Mastra server class, which you import from Mastra server. Okay. So you create Mastra servers from workspaces, basically. So you have to first of all make up a workspace. And if you remember, you can make a workspace by pulling in agents, workflows, and all of that. So you have a workspace, and then you create a server from that workspace. You start the server. Once you start the server, then your front end can call the agents that are in that server, right? And the agents basically become infrastructure. So same thing that LangServe does or LangGraph basically allows your agents to become a backend and can be accessible. So the master server exposes the agent as endpoints, agent endpoints, similar to what LangServe and LangGraph does. It also exposes a streaming API endpoint, so you can call streaming APIs and workflow triggers. So the things that would trigger workflows to happen. And then also telemetry for observability. And you can see how easy it is. Then speaking of observability, we already saw what we could do with Langsmith, right? And it's the same kind of thing, right? Um, just having logs is not enough, right? So you want to be able to see your prompts. You want to be able to see your tool calls. You want to see latency. You want to see token usage. You want to see failures, if there are any failures, why they happened, and to be able to trace them. And even when you have chains of reasoning, okay? Because if not, you start having to do guesswork when you are debugging issues. And that's not what you want to do. So Mastra has observability that enables all of that. So it allows you to see the trace executions. It allows you to see the replay runs. It allows you to inspect tool decisions, to monitor cost, right? And basically that's it. Of course, the recommendation is always set up observability. Otherwise, when you're in production, you have difficulties, right? So it's good to make it a habit early and, master how to set up observability. Then we talked about evals. Evals again is how you measure the performance of your AI agents and tools. And yeah, if you cannot measure it, you cannot improve it. So some of the things that you want to check is whether the agent's responses are accurate, whether it is hallucinating or not, whether the tool selection was correctly called, and whether it was okay or whether there were any issues, right? And whether the output format is correct. So for eval with Mastra, just like in any other thing, you have a set of data sets that you throw into the um, the agent and then see how it performs. So in this case, you can specify the input data and then you specify the expected response from the um, from the agent, and then you can run this across different models, right? So one of the things with Mastra is that um, this becomes your testing data, right? So um, one thing we are seeing is that we are slowly getting to a point where evals will become the basis of doing, regression tests in AI models, which is to confirm if your model has gotten worse or is getting better, right? So you have this whole stack of eval data, which you keep sending, using to eval and check the performance of your models. So Mastra has that built in as well. Then Mastra has voice agents. So we just talked about text to speech, right? So based on text-to-speech capabilities and the fact that it's slowly getting more and more mainstream, especially since the voices are now so human, more natural, you can build a lot of products, right, with natural voice. And you don't need to do API calls, which that's one of the biggest challenges with text-to-speech. It was always that you always had to call out to an API, to do the speech synthesis or even the speech recognition. And that latency is not a very good usability. It's not good for usability, right? You don't want a situation where somebody says something and you'll be waiting for 5 seconds before the response comes, simply because half of that 5 seconds is spent across the wire, an internet API call to a text to speech or speech to text, right? So you now have all of that locally, right? I just demo the one we have on the browser, even though it's not as good as the one that we have, out there on the server because the models are smaller, but at least it's better. And the text-to-speech models are actually getting better and better. Um, the ones on the edge, the ones on the devices that we are having, the ones on the mobile devices, on the browsers and so on, right? So you don't really need to make API calls to get good voice quality and also good recognition quality. So Mastra is looking into this. There is voice that's coming in, right? It's not um, yet you know stable, right? But this really helps because voice is like the natural way to communicate, and it's not all the time you have the time to sit and type. Like if you're even driving, okay, as a good example, or you're doing something else, you can always engage with a voice agent or with an agent through a voice interface, right, to communicate. And voice interface has to become better. The agent has to become better able to understand when it is being spoken to and when you are speaking to someone else and things like that. So it's a lower friction than typing. It's ideal for mobile and it's natural interaction. So Mastra supports it. You can already see what we're saying. You have a speech, you have the speech to text, right? And then that text goes to the agent. The agent does whatever it needs. The response comes back, and then we have text to speech and audio. So the demo I only did the text to speech, right? Speech to text is still a bit difficult to deal with, even as at today. So we'll see where that goes. So, but in the nearest future, we're getting to a point where building a speech interfaces both ways, bi-directional speech to text, text to speech becomes so much easier because frameworks like Mastra will provide that capability. Okay, so this is typically the deployment philosophy for Mastra, right? The idea is that you have a production stack, your agent is part of the production stack, right? So even though you are writing your agent and it's on the front end, but you think about it as part of the backend infrastructure, and we can deploy it to a lot of places. Mastra actually Mastra provides a lot of plugins. There's so much about it that we cannot go into everything. We're just looking at the core capabilities, but it allows you to, what we call deployment targets and so on. It has deployment targets where you can decide where you want to deploy your agents to, whether it's on, servers like Vessel or providers like Vessel, or runtimes, or containers, Docker containers, or Kubernetes, right? Kubernetes clusters and so on. So it simplifies all of that. So some of the key considerations is cold start streaming support, right? Management of secrets, which we already said is a very bad idea to keep secrets on the front end. So how do you manage that? You're not going to store it as .env in the front end because it's always going to get into the compiled JavaScript code. So it's probably better you have a backend where you store it, and also maybe make it possible so users can load in secrets, API keys in particular and others, if you want to give them access to specific services that may cost you money, right? And then other considerations, GPU, do you want to run this locally on a GPU or NPU? A lot of mobile phones now have some measure of AI processing compute power, right? For example, if you're using an iOS phone, an iPhone, you have what they call an NPU, which is a neural processing unit, right there on the phone. And a bunch of other phones too also have small GPUs, right? Or NPUs that can do a bit of processing. So that's where when we talk of edge models, small models that can run on all of these edge devices. So some of the considerations would be, okay, do I want to run this locally on the GPU or NPU or you know, on the device, or do I want to make an API call out to a provider? So this is determined by the difficulty of the problem you're trying to solve. So some problems, maybe for example, text to speech or speech to text, you could run it on the device, but more involved, kind of problems, inference, and so on, you may need to make an API call. But at the end of the day, start simple, right? And continue to improve, implement, incrementally rather. So don't over-engineer too early because you don't even know what the nuances, the constraints are, right? So, and this is the pattern, right? You ship, you put in your observability, and then you scale. So we're going to do a bit of hands-on. We'll start off with just basically setting up Mastra. So I'm going to start again with a new Next.js project. I'm going to do everything on the front end now. I'm not going to do a very fancy user interface, right? Because I want to just focus on what we can do in Mastra. So I'm not going to do a very fancy user interface. But we'll just focus on maybe simple chat um, with with Next.js, and then we'll take it from there. So I'll spend a few minutes on this, and then maybe we'll continue and tidy it up in the next class. Okay, so let's start. So like I did last time, I'm going to use code spaces. I'm going to create a new project. Um, okay, so first of all, I will just create a new project. So I don't have well, let me just create a new repository. Okay, repository. I guess I could have done that from here. Oh, okay, so I'm just going to call this Mastra UI. So this is just for us to try out what Mastra can do. Then I'm going to create code space for it. Okay. Okay. So step one is we'll run this. So we'll just run this too. So start off with this. So the first command is to npx create, right? Create next app. So that's going to create next app. And then we'll put it in this folder called Mastra AI agent. And then we will change directory into that. So let's run that. Okay, would you like to use recommended? Oh, well, yes, yes. I'm just going to use the recommended defaults. Okay, still installing, not yet done. Maybe I'll pause the recording, right? Okay, so we finished installing, right? So now the next thing is to we'll now install Mastra Core and Mastra Server. So we're just going to start with the basic capabilities in those two. All right. So yep. And it's going to create um it's going to create a package. Okay, we already have Next.js. It's going to install that, so we can look at our package JSON to see how it looks like. All right, so those two have been installed. So now we will try a few things now that we have installed that. So if we go back to um, so we'll start off with the folder structure. So we're going to use this. We already have Mastra. We have agents, tools, workflows, workspace, server. So we will implement that. Right. Now, the suggestion is that we should have, well, suggestion is that we should just have Mastra. So I will look at this, right? Even though this doesn't match the standard Next.js, structure, but we'll just go with it. Let's do that. So let's create a folder in here called agent. Another folder called tools. And tools should actually be in here. Another folder called agents, tools, workflows. Another folder called workflows. And then another folder called oh, create a workspace.ts on the server.ts. Workspace. Yes. Server. Server.ts. Okay. All right. So now the next thing we want to do is yeah, so that's just like creating the folder structure. Now, what we want to build is we want to build a front-end AI agent that can summarize or answer questions about page content. So to simulate a real SaaS copilot, okay? So we'll have a next.js UI. It will have a Mastra agent endpoint. Then you have models and tools and streaming response, okay? So this is what we'll implement: page content extractor, summarizer agent, streaming UI, a clean AI UX. Stretch goals would be to add memory, enable follow-up questions, and cite sources. Okay. So yes, so this is basically the guide that we will follow. So the first thing is we'll go to master agents and summarizer, and we will create a summarizer agent in there. Right. And I'll do this very quickly. Um, so we have master agent. Okay. Now this is OpenAI GPT-0 mini. Oh, by the way, I need to install. Oh, okay. I did install Master 4. Um, okay. So agent has an ID. Then the name. So name is okay. Is instructions. So the instructions are more or less like um think of it like It's like a system prompt, basically. That's what. Okay. Um, right. So I'm going to use my favorite model here. Open router NVIDIA. Yeah. So it's nice that they even have this autocomplete, which is interesting. So Nemotron Nano 12B. Either of these I have used before. So right. So you can see that they have automatic routing. So you start with the provider, and then inside the provider, you now give it the ID, within that provider's environment. So this is a very nice way of being able to specify models without having to um, go into much more detail than that. And so that's it. We created this agent, okay? The summarizer agent. Now, um, so the interesting thing with this is that we this summarizer agent is kind of now, you can see that when I made it, when there were a few mistakes here, I got errors. So it is type safe, right? You basically cannot do stuff that is wrong. That's one of the benefits of using Mastra AI. It's type safe, right? So because it's type safe, you will not really make a mistake. And that's why TypeScript is good. It doesn't let you make a mistake. At least mistakes that can be detected by typing. Okay. So um that's it. That's it. So we've created this agent. Now the next thing we will do is we can now create a master server, right? Okay, so let me correct this because I think I put this in the wrong folder. So I needed to create a master folder. So master folder is where you put master stuff, not the app. The app is, so I'm going to put everything that is master in the master folder. Um, okay. Um, right. So the app is just for the Next.js app. So you have the app folder for the actual front end. Um, but master stuff should be in master, and the master folder structure like we saw earlier. If I can go back here, um, and we are going to go do a bunch of these things, but this is its folder structure inside the inside this master AI agent. So you have master, then you have in here you have agents, tools, workflows, workspace.ts and server.ts. So agents, tools, workflows, tools, and workspace. So in the agents folder, we have added a summarizer agent. Now we're going to add a second, oh, before we add that agent, let's add a server. So we already have a server here. We already have a server. So in this server, we are going to put the code for the server, right? And so we will use Mastra server to pull in um, information to set up the server, right? So so right now the the way you set up a server is by using Mastra, okay? And you just create a Mastra and then you specify server, you specify the server properties. So the port, the host. So let's say port is 3000. Host is localhost, or if you use 0.0.0.0 for your host, it means you want it to be accessible outside. So this is how you create a Mastra server using new Mastra. Then you will create a workspace. So you create a workspace. Okay, let's do it this way. I think this is one way of creating a Mastra server, but you could also create Mastra server from workspace. You can also create a Mastra server from workspace by just passing in the workspace. All right. All right. So to create a workspace, we'll import workspace from Mastra core workspace, right? Then there are a bunch of things you can do with a workspace. So one thing you could do is create file system sandbox skills. So let's use this. We'll come to adding the agent. So the local file system you can import. We can also import from here. All right. So we create a workspace and then we create a server from the workspace. So these are two ways of creating. Here, because we didn't specify port and host, this one will be created. We could have also specified server, port. So maybe I should, let's do this. So let's add the workspace here. All right, so this is kind of how you create this. This is if you want to customize a server port and host name. Let me say 0 here. All right, so we create a server. We will put the agent in a workspace later on. Okay. Then we will now create a Next.js route, right? So again, let's go back to so we'll create a Next.js route with streaming, okay, that will connect to that server. So to do that, of course, we'll follow Next.js standard server-side routing. So we are going to create API inside the app folder, which is where Next.js is. We have API summarize route.ts. So that's an endpoint basically, Next.js and API summarize route. So I'm going to put this here. All right, so First of all, we have imported the server from here. Remember, we've already created the server here, right? So we import the server, then we implement a post endpoint. So in this post endpoint, we will create a new instance, sorry, from the master server that we have created here, right? We will then get the agent called summarizer and then stream, okay? Um, so here so um stream has messages. So let me redo this. Okay. So um this is messages should be passed in directly. Okay. All right. So you pass in the when you are calling the stream. So what is happening here is we've created the master server and the agent that is associated with this server will get all of the, remember we have the server has agents. So by the way, let me add this agent. Um, we could do this summarizer agent dot. Uh, let's create the agent here. I think the challenge we have is that yeah, let's do everything in one file. We will create the agent here. So, but before we create the agent, we need to create the workspace. So you create a workspace and then you create an agent. When you have created the agent, you add it to the workspace. So that's a new way of doing it. Um, yeah, so all right. So we create a workspace, then we create that agent, and then we create a server from that workspace. So that's the sequence. So we really don't need all of this. We just do everything in one file. Um, yeah, so now in Node.js, sorry, in Next.js, we create a master, we call the master server. So the post endpoint, we call the master server, and we get the stream, and then um, we stream it basically. So there are a lot of patterns in Mastra, but I think this is kind of like the simplest. Um, and by the way, just like with LangChain, a lot has changed. So it's not, sometimes you find that it's not exactly. So there is the streaming, and you cannot pass the stream directly in. I'll come back to that when we're trying to fix. Okay, so we've done the server, we've done the endpoint. So now what we need to do is let's try this route. So this is basically um let's test it out and see what happens. Okay, npm install AI. Okay, so let's do this. npm. So in order for your the stream from the Mastra server generates a stream in a different format from what AI APIs are used to. So we need to convert it. That's why we're having this challenge. So what I want to do is to install a converter, right? And I think we have, if we're using Next.js, we have AI SDK. So AI SDK is um, it's a library that kind of provides a uniform SDK for basically for for inter should I say for streaming, basically interoperability of the different streaming um, protocols, right? So I'm going to install that, and then that is what we will use. For some reason, it was extracted out of Mastra. All right. It's a separate it's a separate interface, separate integration. So we'll see how we'll use that um, to help us interoperate. Okay, so let's do that. We also need to install AI. So this is another library that we need. Okay, so and then we also need to install Mastra AI SDK, which we didn't have before. So we install Mastra AI SDK, we install AI, and we install AI SDK React. So this allows Mastra to interoperate with AI SDK. And that's what I needed. Okay, so I think running out of space. Okay, so I'm having a bit of technical issue, but I'll be right back. Um, okay, so yeah, let me just finish this up because we've kind of run out of our time. Yeah, so I need to 1 second. Okay, so I need to import this from AI SDK. Um, sorry, not from AI. I need to import this from AI. So this is kind of a standard create UI message stream response. So this is kind of now a standard, and we're going to look at this more when we get in next week. Um, I think all of the AI this is a standard tool that allows us basically to take this stream response and put it straight into so Mastra allows you to use this create UI message stream response to convert the stream that we get from the server, right? And that's what we will, yeah, UI message stream response, and then we'll pass in the stream. So that's the improvement now. Uh, yeah, we don't need to do this anymore. We just return this directly. So that's how this is how we'll stream this, right? So I'll continue this when we meet on Friday, where we'll basically complete what we can do with Mastra. But you can see it was very easy for us to create an agent. In here, it was very easy for us. We created a workspace, right? And when you are creating a workspace, you specify the working directory. So we have a sandbox and then we have a file system. I'll talk more about this when we come back. And then we created a summarizer agent and we specify which workspace that agent will operate in. We specify the model and we also gave it an ID name instruction. And then we created a server from this workspace. Then this server can be called, you know, from we can do any call from it. And when we come back, we will see how we will handle the streaming and how we can basically take this return value from the stream. We can then call this from any user interface component in Next.js, and we'll be able to access this stream and display it. So we'll do that one from next week. But you can already see that Mastra makes a lot of things very easy. We are going to look at other things we can do. Um, tool calls. We are going to look at tool calls. We are going to look at um, um, basically, we're going to look at routing. You've already seen how easy it is in terms of being able to access different. I could basically have changed this model to a Hugging Face model, for example, and we would have it, I could have changed it to Hugging Face, for example, and you will see it even has autocomplete. So this is a Minimax we normally use for our embedding models. So Mastra is really cool for doing stuff with it on the front end. And we're going to, when we come back, we're just basically going to play around with Mastra and do a lot of things with it. So till then, um, this this um this is an interesting one. So we'll see again when we meet on Friday. That's all from me. Messi, you can stop recording now since you are now the host. Are there any questions at this moment? Any questions so far? Okay, if there are no questions, thank you very much. We'll meet. Oh, David, go ahead. I have a question.
Okay, yeah. Good evening, sir. So I don't know, though it's not really like a question, but you know, talking about the streaming for where we have it in the summarized API endpoint. So, you talked about using like another like library for it. So, like I was checking the Mastra documentation for streaming. So I'm seeing like an AI SDK version 5
Yeah.
streaming provider. So I don't know if maybe if that works, or is it
You
like
mean for
duplicate?
what we were trying to do now?
Yes, like yes, for like for the streaming, you know. So those are, you
Yeah,
said
the
you
thing
are
is,
going to do it next week. So I don't know.
I've seen that they're having the same kind of challenge that LangChain has. They had a major change in their API, so the old code is not working yet. But let's look at what we have. Let's see what they have in there. Um, yeah, let's see if we can.
I was I
Let
was
me
even
see if
having
I
that.
can even figure it
I
out.
was even I was even having that challenge with LangChain for the last tax. Some of the
Their
some of
APIs
the
have changed.
providers here, like changed everything. I was having like a lot of issues.
Yeah, so if you look at this, right, this is a example from Masra website. The latest, you can see is latest version, right? So obviously they have changed how they do it. This is the same kind of thing that we are building here. Now, um, the way they have done this is you have the master server, you have agent ID, right? And then you have the parameters. Then it returns a stream. This stream is the same data type as a stream. Maybe it's different because here you have handle chat stream. Um, Handle chat stream comes from Mastra AI SDK, right? And then that handle chat string gives you a stream which they can now put into create UI message stream response. So it looks like um, their own stream format will not directly fit into create UI message stream response. That's what I'm seeing. So it means I have to I can't even use this, right? But I'm going to come back to this. This is a get where you have to AI SDK version 5 messages. So there's a whole bunch of now the create UI message stream response takes a message stream response and converts it into a UI message stream, which is what you would want to consume, right, from your front end, right? But what I have seen, what I have seen a lot of what I've seen is that this is not compatible. So this is a readable stream UI message chunk, and it's telling me that Mastra model output is missing the following properties. So this is a Mastra model output. Let me see what comes from this. It is agent stream messages gives you a Mastra model output. So the Mastra model output is actually not a stream. Right. So let's go check what a Mastra model output gives you and how you can convert it to. Let's see how you can convert it into a stream. Okay, it takes me back to home page. Okay, so Mastra model output. Now let's see. So you have a Mastra model output, which comes, you get it when you call an agent.stream, which is what we have done here. What we have done here is we called agent.stream. Basically, we're just getting the agent from this server and we're calling stream on it. Now that gives us a Mastra model output. But this Mastra model output, um, you have full stream, text stream, object stream, element stream. Now, for us to connect the two, I need to find out what this takes, right? This takes a status text, headers stream, consume stream, all right? So let's look at what it gets. The UI message chunk stream to send. So I have to go find out how to make this into this. I think they have an example where they showed how to do that. So give me a second. Let's see. This AI SDK is one thing that I think you need to really let me share. I'll share this link. This is something I think everyone needs to check out, especially front end folks, because this AI SDK UI is really going to help a lot. It's really going to help a lot with you being able to quickly build your UIs quickly, right? Um, so let's see. So this is just giving me maybe we'll pass a readable stream in. Stream of incremental text content only. Filters out all metadata to calls. Control chunks. That's text stream. Um, so let's element stream individual array elements when the output schema defines array type. So this it has a lot of different things here. And what they are doing here is the kind of challenge I was having. Let's see. let's say if we use readable stream, um, agent.stream. I'm surprised. Text stream, which is declared here. Okay, this is get full output, um, text, object, tool calls, tool. Um, okay. Okay, let me do a type hint. I don't know, it's not